Welcome. We want to talk about functions, but before we do that, let's recall the definition of a relation. So a relation is a set of ordered pairs x comma y, uh, set of ordered pairs, where all of the x values in the ordered pairs is called the domain, and all of the y values is called the range. So a relation is just a collection of ordered pairs. Sometimes it's given as in list notation. So 1, 2, 7, 10, 3, 6, right? A list of ordered pairs. These ordered pairs can also be given by a relationship. So it could be the set of all ordered pairs x comma y such that x squared plus y is equal to 4, something like this, right? This is usually just presented by this thing right here. When we see x squared plus y is equal to 4, we understand that to be a relation between x and y. Also an equation, right? And that's fine. So from this idea of a relation, we want to refine it and give the definition of a function. So a function is a relation, right? A function is a relation. Uh, let's see here. If for each value of x in the domain, there is exactly one value of y in the range. You'll notice that this example here, for each value of x, 1, 7, and 3, 1 is only associated to 2, 7 is only associated to 10, and 3 is only associated to 6. So that satisfies the definition of a function. If instead we had attached another point, say something like 1, 5, okay, let's say that was our relation. Well, this value of x, 1 is related to 2, and 1 is related to 5. And that would no longer satisfy the definition of a function because the value of x of 1 is not associated to exactly one value of y. It's associated to 2. So we want to be able to cite the definition of a function when we justify whether a relation is or is not a function. All right, so to provide a little bit further of a visual representation, I want to create two sets. We'll call this the domain, and we will call this the range. So I'm going to draw a couple of ovals here. And we're going to manipulate these a couple times. So maybe you want to draw a couple pairs of ovals for domain and range. So let's say we have the points. Let's go with 4 points here, and we'll call them 1, 2, 3, 4. Those are the elements in our domain, all of our possible x values. And let's say we have something like 1, 2, 3, 4, 5 points over here. Call it A, B, C, D, E. Just placeholders for numbers. Maybe you want to use actual numbers. That's fine. You know what? Let's do that. Let's call it 3, 4, 7, 9, 10. All right, so let's say that 1 is associated to 3, 2 is associated to 4, 3 is associated to 9, and that 4 is associated to 7, but I've got a 10 over here as well. So let's say that 2 is also associated to 10. So the question is, does this represent a function or does it just represent a relation? So this image, if it's not clear, represents 1, 3 by having 1 attached to 3. It has 2, 4 because 2 points to 4, and so on. Okay. So these are the ordered pairs represented by this image. And we would say, no, this is not a function because this element of our domain is associated to 4 and 10 in our range. So it's not associated to exactly one value in the range. It's associated to 2. So we would have to get rid of that last line that we drew. And now we would have something that is a function. And of course, 10 would no longer be in the range there. So this is a function. Now, I would like to also point out that we could have something like, let's see here, I'm going to get rid of a few things here. Oh, try to get rid of, there we go. Try to get rid of that 10 again, get rid of the line from 4 to 7. And I'm also going to go ahead and draw a line now from 4 to 4. Excellent. So does this represent a function? Yes, this also represents a function. The fact that we are pointing to 4 twice is not a problem at all. The only thing that we're concerned about is how many things do the elements of the domain point to. 1 only points to 3, 2 only points to 4, 3 only points to 9, 4 only points to 4. So there's no worries because from each element in the domain, there's only one arrow being drawn. They're only pointing to one element. So we have this idea of a function. All right, hopefully that gives you a little bit better of a grasp of what a function is. If you have questions, of course, reach out and let me know.